Bonjour. Welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. If you'd like to participate live today, call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television at Bell Express U channel 972. You're always welcome to join me through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 11 till 12 in the morning. And we are now just wrapping up our 8th week of our 9-week course. So next week is our last week. You definitely should be submitting some work for marking. So a reminder that the support questions, the ones marked with the pencil icon, are not for marking, they're just practice. So you decide which ones and how many to do. If you're understanding the concept, feel free to skip questions. You don't need to do more work than you need. You have to decide for yourself. And the answers are in the back. So check your work to make sure you're on the right track. However, mistakes have been found. So if anything isn't making sense or lining up, let me know and we can check to see if that's an error. The key questions, the ones marked with the key icon, are the ones to submit for grading. So please do all of those questions and showing all of your work, your steps, and your thinking. This way I can give you credit for all of the understanding that you have. If you just give me the answer and you've made an error along the way, all I know is that you got it wrong. I don't know why you got it wrong, and if maybe you got the majority of it and just made a last calculation error. So it's really important to show me all of your work. This also means that I can help you if you're misunderstanding something, then I understand what you're misunderstanding so that I can support you with that. How to submit your work, there's 3 methods. The first method is to scan your work in and send it electronically. So if you have a smartphone, you can scan your completed work in through the iPhone Notes app or the Android Google Drive app. If you don't have a smartphone, you can also just take a picture and send it. Or if you want to learn how to use those apps, let me know and I can walk you through it. You can send it through either email to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca. Or you can send it through Facebook Messenger to bslateWahsa. Second method is to drop your work off in Sioux Lookout. So we have an outdoor mailbox at 74 Front Street. We're the big red building next to the post office, and we have a small white mailbox next to our side entrance, so you can just drop it off there. We currently are working remotely, so it may take me a couple of days to pick up your work, but I'll get it back to you as soon as I can. Is to hand your work into your DEC. Your DEC can then either send it your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you have any questions or concerns, please contact me. This is why I am here. So my email address is bronwyn.slate, which is spelled BRONWYN.SLATTE@nnec.on.ca. You can connect with me on Facebook at bslatewahsa. You can call and leave a message for me on the main line at our office, and I can return your call. The number is 807-737-1488 or toll-free 1-800-667-3703. Currently, my office hours are Monday through Friday, 8 a.m. to 2 p.m., and I'll get back to you as soon as I can. If you'd like to connect with me on social media, both my Facebook and my YouTube channel are under the name bslateWahsa. So you can friend me on Facebook or subscribe to my YouTube channel, and then you get notified every time I upload one of our lessons. I do that every afternoon shortly after airing. So that's a great way to keep track of all of our lessons. There's also short videos explaining common errors or confusing concepts on YouTube. If I notice students are struggling with a particular idea, I record a video explaining just that topic. So that might range from 2 or 3 minutes up to 10 or 15 minutes, depending on the topic and how many examples I do. So that can be a great way to go and check out there if there's something that you're struggling with. There may be 1 or 2 videos that address that concept and can help you along. Math is an incredibly visual subject, so connecting to the videos and or the Zoom lessons is really going to set you up for the most success. So if you can't access the replays on YouTube or show up live, that's totally fine. But just let me know if you don't have reliable internet and you need a copy of the videos, and I can send them to you. All right, we're on day 31, the last day of week 8, and we are doing our final Throwback Thursday. So next week, from Monday through Thursday, we will be doing a review of each unit for each of the days. So just to recap before you do your final assessment. So today is our last day of reviewing, focusing specific on lesson 8-13 through 20, but of course covering the entire course a little bit. So the benefits of reviewing frequently, at this point, we have consistently done this through the entire course, every week reviewing what we've done the past week and the previous weeks. And the reason that we do this is because we know through research that we forget things really easily, really quickly, and we forget a lot of it. So we do not retain information very well if we just learn it once. So when we first learn it, if we completely understand it and we are comfortable with it, great, we know it. And then as soon as we stop doing it, we stop focusing on it, we are losing that information. Our brains aren't holding that, they're making space for new information. And so reviewing frequently means that we continue to keep hitting back on those topics, and we're bringing that retention, that knowledge back up to 100%, and then we don't forget it as fast. So if we continue to retouch on those topics, not only are we remembering more of it because we are going back up to 100% every time we review, but we also remember it for longer, and we don't have to necessarily review it as frequently. So that's why we have been reviewing every week over the entire course, so that now that we are at the end of the course, you don't have to think back all the way to lesson 1 or 2 and be like, what was it that we're doing? Hopefully we've hit on a couple of times in the last few weeks that you remember a little bit about it. If you don't remember everything, that's great, that's fine, but you remember a little bit that you're not having to relearn everything all over again. So first, before we dive into the review, we're going to do our brain activation, our mental math. Hopefully you've enjoyed these and have found them useful. So we know that I'm not a fan of the mad minutes that many of us experienced in elementary school, where we had to sit in a desk and sit with a whole paper of math facts, either multiplication or subtraction, lots of times, and do as many as we could in a minute. And this just caused a lot of stress and anxiety in most students and didn't actually teach us anything. Either you knew them, great, you could write down the facts, or you didn't. It didn't actually teach us how to do these facts or strengthen them. They just were really emphasizing on memorization and, as we say, drill and kill, which is not beneficial. So instead of doing that, we work on strategies that we can use in various situations and that really work on our own comfort with the numbers, so that we're not just memorizing things, but really truly understanding, which means that we can apply it in various situations. So our question today is 12 times 29, and we're using the strategy of making a landmark. So how we're going to do that is I'm going to say, okay, well, 12 and 29 are not particularly friendly numbers, but 29 is really close to 30. So I'm going to instead think of 12 times 30 and then modify that to get back to what 12 times 29 is. So 12 times 30, I can think and say, okay, well, I know that 12 times 3 is 36. So 10 times that amount, because 3 times 10 is 30. So 12 times 30 is going to be 360. So that I was able to do fairly comfortably. But to go from 29 to 30, I didn't just add 1. So my answer isn't just going to be 359 if I am trying to go back to 29, but I added one group of 12, right? Because for every 29 to 30, for every amount here, we're actually doing 12 units, if that makes any sense. I don't think I explained that very well, but we're doing one group. We're increasing by one group each time. So in order to figure out what 12 times 29 is, if I know that 12 times 30 is 360, I need to take away 12. I need to take one group of 12 away from 360. So if I take one group of 12 away from that, so I'm going to say, okay, well, 360 take away 10 is going to be 350. And then 350 take away another 2 is going to be 348. That's how I do that in my brain. So that means that 12 times 29 is 348. And that's how we can make a landmark. We can make a number that, change one of our numbers to something that is easier to do, easier to deal with, and then modify depending on the groups, the number of groups that we increased or decreased by. All right, let's recap. Let's just do a quick run through of all the courses that we've covered, or lessons that we've covered so far, and then we'll go into detail about what those lessons were, and then we'll do some practice. So lesson 1 was transformations of quadratic functions. 2 was polynomials and factoring. 3 was solving and graphing quadratic equations. 4 was exponent laws. 5 was simple exponential equations. So that was unit 1. Unit 2, lesson 6 was simple interest and linear growth. Lesson 7 was compound interest and exponential growth. 8, compound interest formula. 9, loans and RRSPs. 10 was buying new and used vehicles and vehicle costs. So then lesson 11, beginning of unit 3, was trigonometry ratios. 12 was a sine law. 13 was a cosine law. 14 was trigonometry and problem solving. 15 was creating nets. And then our final unit 4, lesson 16 was sampling data. Lesson 17 was measures of central tendency and standard deviation. 18 was data distributions. 19 was theoretical probability. And 20 was probability and statistics in the media. So that's all of the material that we've covered. It's the entire course. And now let's remember what those actually were. So let's look at the highlights of each of those lessons briefly. So looking again at the things that we did this past week, the things that we haven't covered the most, they just the newest information. So lesson 18 was data distributions. And so this is where we used histograms, which are like bar graphs with touching bars because the data is continuous. So there's no breaks in the data. We have, you're moving through the data completely. And we used data frequency in intervals in order to create those histograms. And then we analyzed those histograms and we had a normal distribution, which, was symmetrical around the mean, and the mean, median, and mode were all equal. We had a bimodal distribution where we had 2 peaks and 2 modes, so 2 more frequent occurrences of data. We had left skew distribution where the tail is on the left side and the peak is on the right. So that's really important to remember that when we're talking about the left, the tail is on the left, which is opposite what my brain wants to do, but I'm working on it, which means that the mean is less than the median, which is less than the mode. And then we had right skew distribution where the tail is on the right side and the peak is on the left, where the mean is greater than the median, which is greater than the mode. So the mean would be over here, the median would be here, and the mode would be here. All right, so then lesson 19 was theoretical probability. So theoretical probability is when we're measuring the number of desired outcomes divided by the total number of possible outcomes. So this is not us actually doing experiments and counting things, but just doing it logically based on what we want and the possible ways that we can get what we want out of the total number of possible things that could happen. We used tree diagrams where we had branches that for all of our outcomes, including the probability of how likely that would be. And then we calculated probabilities so that remembering that when we had multiple events, that we would multiply the probabilities for each event in order to figure out how likely both of those things or all of those things happening would be. And then finally, we had lesson 20, which was probability and statistics in the media. And here we talked about how statistics can be a powerful way of communicating information, that they can make things clearer and more accessible to understand. But statistics can also be incredibly misleading. And therefore, it is essential to think critically about the information presented to us by the media and really think about the use of probability and statistics in the world around us. So then going way back to the beginning of the course, remembering what unit 1 was. So lesson 1 was transformations of quadratics, where we had A in our general formula of y equals A times x minus h all squared plus k, where A tells us the opening direction of the parabola and H told us the horizontal shift, and K tells us the vertical shift of the parabola. Then we had lesson 2, where we had polynomials and factoring, talking about how expanding was meaning multiplying according to the distributive law, so making sure that everything is being multiplied by everything, and that factoring was when we were finding the 2 binomials that resulted in the trinomial product. So taking our trinomial, our 3-termed expression, and figuring out what would multiply to make that 3-term expression. Then lesson 3 was solving and graphing quadratics. So talking about how solving quadratic was meaning that asking what values of x result in y equaling 0. And this happens on our graph. We think about this as our zeros or x-intercepts, where our parabola crosses our x-axis. And 4 were the exponents, where we had multiple laws that helped us understand how to effectively deal with exponents when we have the same base. So for multiplication, that means that we would add our exponents. For division, we would subtract our exponents. We had a power of a power, so we had an exponent that was further to the exponent. We would multiply our exponents. If we had the unique case of having a 0 exponent, that would mean that our overall base our entire expression would equal 1. And when we had a negative exponent, in order to simplify that or to evaluate that, really that means that we have the reciprocal of the base. So generally we have 1 over our base. So that can sometimes get a little bit more complicated. And then lesson 5, we had simple exponential equations, where we were talking about equations in the form of y equals a times b to the exponent x, which is a very fast change, either as growth or as decay, getting smaller. Then looking at highlights of unit 2, lesson 6, where we had simple interest in linear growth, where our pattern was increasing or decreasing at a constant rate. We calculated this by finding I, so our interest is equal to PRT, which is principal times rate times time. And if we wanted to find our total amount that we would be earning, we would have to take our principal P and add it to I, our interest. 7, compound interest and exponential network growth. So this was talking about how when we're compounding, we are increasing or decreasing with a constant ratio, so really rapidly. Use the formula A equals P times 1 plus R over N, all to the exponent NT. And if we wanted to find our interest, we had to do A, our total amount, take away P, our principal. Lesson 8 was compound interest formula, what it's called. So this is still doing compound interest, but doing some problem solving so that we identifying that we needed to be compounding. So our problems had to talk about compounding, and that we would have to rearrange our formula so we could find the principal or the interest rate or the time. And sometimes we need to use the nth root or the guess and strategies for when we're doing interest rate or time, as those are how we would use the algebra. It's a little bit more complicated. Lesson 9 was loans and RSPs, where we had lots of formulas. So about borrowing money that must be paid back with interest, and that we could figure out the payments based on how much we borrowed or how much we could borrow based on how much we could afford on payments. And we had these more complicated formulas. For one is PV, so the present value is found by doing R, your payment, times 1 minus 1 plus I, all to the exponent negative N, all divided by I. So again, these are things that you don't need to memorize, but you can look up, and you need to understand how to use them, opposed to having to have them memorized. I don't have them memorized. And then we also looked at RSPs in this lesson, where we figured out that once you retire, you can be putting money into an RSP, and that can be gaining interest over regular payments over while you're working. And then once you retire, you can set it up so that you receive regular payments. That investing earlier means that you have more money in the long run. And then we had formulas for making contributions, but then also receiving payments like your loan payments. Again, you don't need to memorize these. You will have access to them for your final exam, and you should always be able to look them up if you need them. Then lesson 10 was buying new and used vehicles and vehicle costs. We talked about buying a new vehicle and calculating the monthly payment and completing a deal review, so all that was involved in buying a vehicle. We talked about buying a used vehicle and calculating depreciation values, how much a vehicle is worth after it's not brand new. And then we also talked about the cost of owning a vehicle, particularly the fuel costs and also the monthly average costs, which include fuel, maintenance, insurance, and licenses. Then unit 3, lesson 11 was trigonometry, where we talked about right angle triangles and SOHCAHTOA. So using sine, cosine, and tangent as your 3 primary trig ratios to solve things. Then lesson 12 was a law of sines, where if we did not have a right angle triangle, but we know 2 angles and a side, or if we know 2 sides and an angle that is opposite one of the sides, we could use the sine law to solve for both the angles and the sides, depending on which would be easiest. Then lesson 13 was the law of sines, which again, we don't have a right angle triangle, but in this case, if we know 2 sides and a contained angle, or we know all 3 sides, then we can use the cosine law, either for angles or sides, whichever one would make our life a little bit easier. Lesson 14 for trigonometry and solving problems, we did word problems, where we need to identify the trigonometric strategy and what would be best in each situation for primary trig, the sine law or the cosine law, based on what we know. We also talked about the angle of elevation, which is when you're looking straight out at the horizon and then up to an object, or the angle of depression, which is when you're looking straight out at the horizon and then down to an object. Creating nets, which is when we had nets, which were a flat version of a 3D object that can be folded to recreate that. Patterns, which means that the flat version of the 3D object needs to be reattached so the parts were separated. And plans, where your flat object shows the front, the side, and the top so that you can reconstruct it. And then finally, unit 4, lesson 16, we're sampling data, where we talked about population and sample as our vocabulary, and we talked about types of sampling, which were random sample, systematic, clustered, stratified, convenience, and self-selected. And then lesson 17 was measures of central tendency, standard deviation, where we talked about the mean, median, mode, and range variance and standard deviation. So we have done a lot, and I just raced through recapping them, but now we're gonna do some practice to hopefully figure out what strategies we need to do for what situations and going from there. So number 1, a golfer hit her tee shot so that it landed about 7 yards behind a 40-foot tall pine tree. She decided to take her second shot and hope the ball would make it over the top of the tree. She used her lob wedge and hit the ball, setting it upward at an angle of 60 degrees. Was she able to clear the top of the tree? Now, I don't know anything about golf, but I am going to interpret this question. And so sometimes there's enough information, even though you don't know anything about what's going on, there's enough information to figure it out. So I know that I have a tree. So I'm going to draw myself a picture to help me visualize what's going on. My beautiful artwork, which I know you all appreciate, which is 40 feet tall. And then I have a golfer is 7 yards away from that tree. And she is going to hit ball on a wedge, which is helping me tell me that I know that it's going to be hit up, like the wedge I can assume is going to hit up, and it's going to go up at an angle of 60 degrees. And I'm trying to figure out if, when I do that, if I actually go more than 40 feet or not. If she doesn't hit 40 feet, she's going to hit the tree and not make it over. So our goal is to get over, not just through, to get all the way over. So I need to figure out, is this length 40 feet or more? One thing to note is that I have different units. I have yards and I have feet. These are imperial units, not metric, which the joy of Canada is that we often use both metric and imperial systems instead of just sticking with one. But we're going to convert these so that they're in the same. So I know that that 1 yard is equal to 3 feet. If you didn't know that, you can look this kind of information up. So that means that 7 yards is 21 feet. So I want to have both my units. I want to have them in the same. So if I were to do this and I would calculate it in yards, and I might say, okay, then I have this many yards, and I wouldn't know if it actually hit my number if I went over my 40 feet. Okay, so now that I've done this, I have an angle and a side, I'm going to assume that this tree is growing at a 90-degree angle, because in theory, trees grow straight up. So that means that I'm looking for my opposite, and I have my hypotenuse. Oh, no, sorry, I have my adjacent. Oh, geez. So that means I'm doing tan. So I'm going to do tan of 60 degrees is equal to my opposite over my adjacent. So tan of 60 is equal to opposite over 21 for feet. And then, so my opposite is 21 times tan, this is times 60 is equal to my opposite. So using my Desmos calculator or your own calculator, we're going to do 21 times tan of 60. And that gets me 36.3 feet. So my opposite side is 36.3. So does this golfer get over the 40-foot tree? No. So then we answer the question. No, she wasn't able to clear the tree. Now, if you didn't want to assume that this was a right angle triangle, which is totally reasonable, we weren't told that it was, you could also try to figure out it using the sine law, and if you had enough information. I don't feel like we did have enough information to do it, so that we'd have to assume that it's a 90-degree angle, but I'd have to think about that a little bit more whether or not we can use the sine law or not. All right, question 2. When rolling 2 dice 60 times, doubles turns up a total of 15 times. So because this is saying that we rolled the dice 60 times, this is an experiment. We did the experiment of rolling it 60 times and doubles turned up 15 times. So doubles meaning 2 of the same number were rolled because we're rolling at the same time. So what is the experimental probability of doubles? So how many we got? 15, that's how many successes were the doubles, divided by the total number of rolls of outcomes was 60. So then we would simplify 15 over 60. I know that they're both divisible by 5. I can start with that. So 15 divided by 5 is 3. And 60 divided by 5 is 12. And then now I see that these are actually both divisible by 3. So 3 divided by 3 is 1, and 12 divided by 3 is 4. So 15 over 60 reduces down to 1 over 4. So 25% chance of getting doubles in our probability, in our experiment. So what is a theoretical probability of rolling doubles? So remember, the theoretical probability is equal to the number of desired outcomes divided by total outcomes. So we have to think about how many ways can we get doubles out of how many ways we can roll the dice. So doubles are going to be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Those are the only ways that we can get doubles when rolling 2 dice. So we have 6 ways that we can get doubles when rolling 2 dice. Now we have to think about the total number of things that we possibly could get. Well, if we could do a tree diagram, but it's going to be a lot because we're going to have 1, 2, 3, 4, 5, 6, and then for each of those 1, 2, 3, 4, 5, 6. So the total possible answers that we can get, well, there's 6 choices for our first dice, and there's 6 choices for our second dice. So that means in total, there's 36 total outcomes that we could possibly get. If you want to do a tree diagram, you totally could to see all those. I'm just, for the sake of time, not going to draw that out. It'll take me too long. So 6 out of 36. Well, I know that 6 and 36 are both divisible by 6. So that's going to be 1 out of 6. So the theoretical probability of rolling doubles is 1 out of 6, which is about 16%, I believe. If I do 1 divided by 6, Yeah, it's about 17%, 16, 17%. So answering question C, do you think the dice are fair? Why or why not? Well, we rolled that doubles 25% of the time. But we expected to roll doubles 17% of the time. And this you could do 1/4, 1/4, or 1/6, just doing numbers that might make me more meaningful. So it seems the dice aren't fair. As it seemed like we had a higher chance of roll. We rolled doubles more frequently than expected. So we can't guarantee that they're weighted or unfair, because potentially if we'd done a lot more trials than just 60, we could have gotten down to being 1/6% chance, or 16, 17% chance, 1/6. It isn't guaranteed that just because when you're doing experimental probability, it's very unlikely that it's going to be exactly the same as your theoretical, unless you do a million trials. Like, you really need to do a lot of trials in order for them to actually be equal. But still, it seems it's fairly high in comparison to what the theoretical probability would be. All right, number 3, the manufacturer of rechargeable batteries tests 10 batteries at random and records the time it takes in minutes to drain each battery after a fully charge has been applied. Find the range, the variance, and the standard deviation of the data. Does this seem to be a reliable source of rechargeable batteries? So we have 10 times of how long these batteries drained, and we need to see, does that really vary a lot or very little? In order for being a reliable source, we would want to know consistently. Maybe there's not a great source. Maybe we don't have amazing batteries that have a really, really long lifespan. But if we know what to expect, that means that it's reliable. So for the range, remember to calculate the range, we take our highest value and we subtract our lowest value. So our highest value, so we've got 203, so my values are 195, 203, 177, 186, 191, 225, 216, 205, 197, and 218. Remember, these are minutes. So 225 is my highest minutes, my highest amount of minutes. And my lowest, I think, is 177. Yeah, that looks like it. So 225, take away 177. That is 48. So our range is 48 minutes. So that just tells us, to me, that seems like a fair amount of, that's a fairly large range. Like, that's almost an hour of difference between our batteries. Like, if you're expecting something to be 3 hours and it's only 2 hours, or if it's 4 hours, that's a really big difference. So, but we need to calculate the variance and the standard deviation to figure out, well, is most of our information at one of those ends or the other or in the middle? And that's going to still tell us how reliable it is. So for our variance, remember, we need to calculate the mean. So I'm just going to do that over here. And with the mean, we add up all of our values and we divide by the total that we have. So I'm going to do that on decimals. And I have to 195. Oops, got to clear my previous information. 195 plus 203 plus 177 plus 186 plus 191 plus 225 plus 216 plus 202 plus 197 plus 218. So that equals 2010. And then we know that we have 10 batteries. So we're going to divide 2010 by 10. And that's going to give us 201. So our mean is 201 minutes. So then for our variance, we need to remember, we need to calculate what the difference is from each of our points. And then we square them and add them together. So to figure out our difference, so from 195 take away 201 is a difference of -6. 203 take away 201 is 2. 177 take away 201 is -24. 186 take away 201 is -15. 191 take away 201 is -10. 225 take away 201 is 24. 216 take away 201 is 15. 202 take away 201 is 1. 197 take away 201 is -4. And 218 take away 201 is 17. So those are our differences. So each of our points, how far away they are from the mean. And then for the variance, we then go in and calculate. We're going to square each of these values and add them up. It's our next step. So I'm going to do that all in one step. Remember, you have to make sure that you're squaring properly on your calculator so that you're doing -6 times -6 and not just 6 times 6 and then applying the negative afterwards. It's really important. So -6 squared plus 2 squared plus -24 squared plus -15 squared plus -10 squared plus 24 squared plus 15 squared plus 1 squared plus -4 squared plus 17 squared equals, or not equals, 2048. And then what we do is we divide 2048 by n take away 1. So by the total number of our tests minus 1. So 10 take away 1 is 9. Oops, forgot to do divided by 9 is equal to 227.55. So the variance is 227.5, really 56. And that means that our standard deviation, remember, is the positive square root of 227.56, which is equal to 45. Sorry, that I didn't do right. No, is equal to 15.09. So our standard deviation is 15.1 minutes. So that's a lot closer within our battery reliability. If they vary from 15 minutes, that's a lot less than thinking that they vary by an hour. So I would say that this is a reliable source. Batteries. Because they really generally just vary by 15 minutes instead of an hour. Okay. Number 4, each problem has at least one error. Find the error and describe the incorrect step, then correctly solve the problem. So we have two expanding binomial questions, and we need to find they're completed, but we need to find the mistake that was made. So our question is 7v minus 8 all times negative 6v minus 2. Now we could go through and do this calculation on our own, but it's really important when you're checking your own work is that you've assumed that you've already done it. So you need to go back and look to check your own work to make sure that what you've done is accurate. So instead of doing it ourselves, we're going to go back and look at each term. So 7v times negative 6v, we have v squared, so that's right. 7 times 6 is 42, that's right. And negative 6 times positive 7 is going to be negative 42. Okay, so then our next term is negative 14v. So that means, to me, looks like we have 7v times negative 2, and that would be negative 14v. Then we have 48v. So to me, that looks like negative 8 times negative 6v, which is going to give me 8 times 6 is 48. Negative times negative is positive, and a v. So plus 48v's, right? And then we have plus 16, which is negative 8 times negative 2, which I agree with, that that's 16, and negative times negative equals positive. So I say that this first row is right. Great. So then I have to look combining. How did I combine them? So negative 42v is still there. Negative 42v. Great. I didn't change that. I shouldn't have. And then I have negative 14v plus 48v is equal to negative 34v. Well, if I think about that, okay, so negative 14v plus 48, so I'm getting bigger because I am at negative 14 degrees and I've increased by 48 degrees. So that means that I'm getting warmer. But, and 30, the difference between 48 and 14 is 34, but it shouldn't be minus 34. It should be plus, because this means that I got colder, right? Minus 34 means I got colder and I should have gotten warmer. So the mistake there is that instead of being positive 34v, it's negative 43v. So I've changed that to a positive. And then the 16 is still the same. So there's the error is integer arithmetic. I always spell that word wrong. Integer arithmetic. And I spell arithmetic wrong too. Okay, so then part B, we're actually, you know what, we're going to skip part B. It's the same idea, going through each one and finding a mistake. And we're not actually going to correctly solve a problem. We could, but we just corrected it here. But just for the sake of time, we want to keep going. All right, so question number 5, calculate the regular quarterly deposit needed to make so that your RSP has $100,000 in 20 years at 5.5% annually, compounded quarterly. So this is an RSP. This is saying that I am trying to figure out how much my deposit is, so how much my payments are. A regular quarterly deposit would be a regular quarterly payment. It's another way of thinking of it, into an RSP. So I'm going to look at my formulas and I'm saying, okay, I'm contributing to an RSP and I want to find the payment. So that means that I'm looking for R equals AI all over 1 plus I to the exponent n minus 1. So I need to know, okay, so A is the amount that I want at the end. So that is 100,000. And I is my interest rate. So it is 5.5%. So that's 0.055. But remember, we have to know that it's compounded quarterly. So we have to divide that by 4. And then N is equal to my number of payments, like my number over. So for 20 years, I'm doing it quarterly. So that's 20 times 4. So that's 80. So then now I'm going to input that in. So I have 100,000 times 0.055 divided by 4, all divided by 1 plus 0.055 divided by 4, all to the exponent 80, take away 1. So we're going to do that on our Desmos. calculator. And as I've said before, we need to be really careful about how our calculators do our calculations. So they want to follow, the calculator wants to follow order of operations. And so if it doesn't know what you're talking about, then it won't necessarily do what is accurate, what you mean. So I think Desmos is great because you can put it in the way that you see it, and that might be really helpful. But if you're using a different calculator, you just want to be really careful about what is going to be happening first. Are you going to be doing your order of operations first? You're going to be doing your addition first or your division. What do you intend? And then what is it actually doing? Could be two different things. So there, I calculated it all in, it's all in accurately, and I get $11,833.68. $11,833.68. So that's what your payment. So your payment you would need to make quarterly deposit of $11,833.68 to have $100,000 for 20 years. Okay. Question 6. Analyze the March Madness viewing trends by age. We have this graph on our screen. And what do you wonder? What do you notice? So we have, this is an image I found online, and it shows us that it's comparing cable TV, over-the-air broadcast, and streaming, and age ranges. So we don't have a frequency on our vertical axes because they just labeled it on top of our bars. And we actually have 3 graphs in one. So we have cable TV, which is this dark blue, is these. So if you can sort of see that relationship. And then red is the over-the-air broadcast, and those are these red bars. And then streaming is these lighter blue bars. So they've superimposed 3 graphs on one in hopes that you can sort of still see the trends for each of the medias. So we're just analyzing it. We don't have a specific question, but we're trying to see what do we notice and what do we wonder. So we can see for cable TV, from 18 to 20-year-olds, we have 40%, 25 to 34-year-olds, we have 51%, 35 to 44-year-olds, we have 63, 45 to 54, 72, 55 to 64, 70, and 65 and older is 75. So if you look at this general shape, you can see, or hopefully you can see, that we have a scale is on the left, so we have left skewed. So cable TV is a left skewed distribution. So then let's see what we notice about the other ones. So let's get a different color. So for the over the air broadcast, which I had to look up, and that's like having an antenna. So for the over the air broadcast, I would say that it's pretty uniform. I mean, we have one outlier between, sorry, I didn't read them. From 18 to 24, we have 1%, 25 to 34, 4%, 35 to 44 is 5%, 45 to 54 is 4%, 55 to 64 is 8%, and 65 years older and older is 7%. So I would say that for over the air broadcast, so like antennas, it's pretty uniform and low. Uniform, but low values. And with an outlier of 18 to 24 years. Those folks really are not using old school technology. And then our final one, we have for streaming, we have 18 to 24 is 59%, 25 to 34 is 45%, 35 to 44 is 32%, 45 to 54 is 24%, 55 to 64 is 22%, and 65 years and older is 18%. So again, if we draw sort of a line of that shape, we can see our tail is on the left, sorry, it's on the right. So this is our right skewed. So for streaming, it's right skewed distribution. So most folks who are younger are using streaming, and most folks who are older are using cable TV. Okay, last question. So a study by Health Canada has shown that by the age 14, 1 in 4 teenagers have tried smoking tobacco. This might be old stats. I couldn't guarantee that I had new stats that I was really comfortable with. So this is from an older textbook. But anyway, assume that it's something similar. Of those who try smoking, 36 become regular smokers. So what is the probability that a person has not tried smoking by the age of 14? So if 1 in 4 teenagers have tried smoking by the age of 14, that means that 3 in 4 haven't. It is the opposite. So 3 in 4, so 75% have not tried smoking by 14. Then B, what percentage of people who have tried smoking do not become smokers? So this, we're going to use a tree diagram. So we have our first option is we have tried smoking and not tried. And then from there, we know that if you tried, you become a smoker or not become a smoker. We don't know the stats for if you haven't tried smoking, the percentages of chance of becoming a smoker or not smoker by 14. So that we're not going to do another branch for that because we don't know. So the probability of trying smoking is 1 out of 4. So that is 25%, and 75% is not trying. And then we know that 36% of people who tried by 14 become smokers. And that means that 64% become not smokers. So what percentage of people who've tried smoking do not become smokers? So this is out of all people. So that means that we need to do the probability of tried and not smokers is equal to the probability of trying smoking by 14 times the probability of not smoking. So probability of trying smoking is 0.25 times the probability of not smoking, which is 0.64. So if we calculate that, we have 0.25 times 0.64, which is 0.16. So 16% who have tried haven't become smokers. All right, so we had one more question about looking at the numbers in relation to Inuit, Indigenous, and Métis populations because their smoking levels are much higher. But we have run out of time, so we won't look at that or analyze the inherent racism and intergenerational trauma that attributes to that. Unfortunately, we don't have time to have that conversation. It's much too large. But at this point, we are finished our course. We've done all 20 of our lessons and we've covered them all. So please submit your key questions so that you can get them marked to get them back so you can do your commenting activity. As always, connect with me in the various ways through phone, email, or Facebook. This will be up on YouTube this afternoon, so you can check it out again if you'd like to. Thank you so much for joining me and good luck with wrapping up your work and sending it to me. Miigwech.